Going to be talking about outside testing. My name is Nick Gauthier. That's my Twitter. If you want to hear about other things that I say, just going to warn you, it's mostly cats. So I've been doing Rails and JavaScript for about 6 years now. I learned on Rails 2 beta, and I remember being really annoyed that the books that we had were on Rails 1, and my boss was making me learn 2 beta, and but I guess it's for the best. And also, I guess you could have figured this out. I love testing. In fact, I test, which I can never really say. But you can ask Brian Lyles about that. That's one of his favorite things. I write code for other people. Of my 6 years experience, 5 years of that has been in freelance or consulting. So in that world, how many people have done freelance or consulting? Okay, yeah. A lot of Ruby people do tend to do some freelance. I think that's a big way that people kind of get into the business. It's definitely a great way to learn, and it's really great experience. So when you're freelancing and consulting, your clients generally want code very quickly. They want to see results, they want to see them fast. They also like things to be very cheap because they're paying their money for your time. And when we build things ourselves, we love to just shave yaks all day and just do whatever we feel like and waste tons of time and learn things. But when we're doing client work, we have to keep it quick and cheap. And personally, and I hope I share this sentiment with the rest of the community, I refuse to make it bad. And so everybody knows the good, fast, cheap triangle. Pick two, you can't have the other one. And we all just try to get as close to all three as we possibly can. So what that means is that if I want things to be good and fast and cheap, I have to be very efficient. So that's one of the reasons that I test from the outside in on an application. I like to write my tests from a user's perspective. This might be the client that I'm building the software for because it's really their needs and expectations that I'm trying to fulfill. Hopefully it's the actual users of the application, but I always try and keep that perspective in mind. To me, if all my tests pass, it means that the people who use my software can use my software. So I write my features before code, test-driven style, meaning that the first thing I do is think about what people need to do with the application, and I describe it in some way. And then I figure out how to decide when it is in fact true that people can do that thing with my application, and that becomes my test. Once I've decided what success looks like, I can then go on and implement code to actually pass that test so that I can deliver that feature to the user. So those tests are driving the code that I write. And I'm going to assume that most people here are already doing TDD in some form. That's an entire talk all on its own about why you should be doing TDD or BDD, how to do it, and so on. How many people here are familiar with TDD or have done it? Or yeah, okay, great, awesome, I love that. A couple years ago, we were really pushing it, and then we had a great boom of testing it, so that's been really wonderful. So I'm not really going to be talking about how to TDD, but rather what I decide to TDD on my application. So why do I want to go from the outside in? This is a slide that I took from Sandy Metz, because everything is Sandy Metz this year. It's wonderful. She has great, amazing things to say. And in that, there's this slide, the unit testing minimalist. And I'm going to go over this slide because I'm sure there are some people who are familiar with it. But I want to make sure that you totally understand it. So this is a grid of the kind of messages that an object sends and receives. So at the very top left, we have incoming queries. And that's when you say to an object, tell me something about what you do. You might be saying like person.age. You want to know something from that object. It doesn't really do anything, but you're getting a piece of information. And the way that you test that is by inserting the result. If I say that there's a person whose age is 20 and then I ask it its age, it should be 20. The next incoming message is an incoming command. That's telling an object to do a thing. And the only way to really tell if it did that thing is to assert on the direct public side effects. So if I say person.buy new car, they're going to go, okay, I did. But you can't trust them. You have to go and actually look in their garage and make sure there's a new car there, right? That's looking at the side effects. In the middle, we have send to self. That's all the things that an object does under the hood where it calls its own methods. You can ignore those because they don't really affect the end result. They don't affect the result of a query coming out. or side effects. If they do affect the side effect, it's the method you called that then called those internal methods that you should be checking. Then we've got the outgoing methods. When an object sends an outgoing message to another object, you can ignore that because that should be covered by an incoming message for that object's unit test, right? So if a person asks the car what its license plate number is, I can just test the car over here. I don't have to do that as part of the person test. The last one are outgoing commands. So that's when the person says, like car.refuel, and the car's fuel tank should now be full. When I tell the person to refuel all of their cars, I need to go and check the cars. And in this case, we're saying we're going to inspect around that car and make sure that the car actually got the refuel commands from the person. So we're making sure that the person and the car are appropriately connected for those commands. Does that make sense to everybody? And please stop me if you've got any questions along the way if you want me to clarify a slide. But if you've got a bigger, broader question for discussion, we'll save those for the end. Okay, so I just scratched out the little unit. Now this is my slide that I made. I used Comic Sans. This is the outside-in testing minimalist. The same grid applies, except you replace unit with the entire application that you're making, right? So what I'm saying is, instead of looking at each unit of your application, like the models and the controllers and all of that stuff, treat your application as a whole as a unit. Outside-in tests are unit tests on your entire application's interface. So what's an incoming query look like to a Rails application? That's something like what's on the page. I clicked on my dashboard. I want to see how many emails are in my inbox. Oh, my application says I have 7 emails. That's kind of an incoming query to a Rails application because you're looking, asking the application something, and seeing through its user interface. An incoming command are when you click links and buttons and you fill in fields and you hit keys on your keyboard and you're doing something. So you're clicking the compose button and you've got this new email window, you type something in and you hit send and it says your message has been sent. That's a command you sent to your mail client that says go off and do something for me. So what about send to self? That's everything your application does, and we're totally going to ignore it. So I'm going to talk about that one later. For now, let's talk about Capybara. How many people have used Capybara for testing? Awesome. It's a great gem. So what we're going to do, just to illustrate the process of doing an outside-in test, is to write a test. So here I have one of the first tests that I tend to write on an application, which is a registration test. So let's walk through this. We're going to visit the root of the application. That's roughly equivalent to the user typing in their URL, or more likely, typing in your name into Google and then clicking on the URL, right? Now they're on your page. So what are the things that people do on your app? How are they interacting here? They're clicking the register link. Then they're going to fill in their email with their email address. And they're going to fill in the password with the password that they're going to register with. And then they're going to click the register button. Now it's time to do our assertions. So we're going to assert that the page says activate via email, because one of the things with our application is that it should tell the user, hey, you're going to get an activation through your email address. So this is kind of like a query here. Then the next thing I'm going to do is I'm going to open an email. That's the Capybara email gem, which is by Dockyard's Brian Cardarella, who organized the conference. He didn't pay me to put that in there. So we're going to look in his email address, and we're going to click on the link, activate your account. And then I'm going to assert that the page says your dashboard. And I'm going to use that as proof that I've actually logged into the application. So you'll see what I've done here is very simple, and it's all things that a user could do with their eyes. You could take this as a script and give it to a real person, and they could read this, and they could fill it out. Like if you gave this to a Ruby developer and you said, go visit this website over here, they could check the boxes and click on the things and do all that stuff. But what I didn't access here are the models. I didn't look to see if there was a user model that had that email address. That's something I'm considering internal and sent to self within the black box of my application. If you're going to be purely outside in, then you're not allowed to actually touch the models, look at the controllers, inspect queries in the database, that sort of thing. The only exception to that, and we'll talk a little bit later, are those outgoing commands where there are side effects to external services, right? Right now we're talking about things that happen inside your application. Okay, so from here, you just TDD and your code happens, right? So every step of the way when you're doing TDD, that means you're going to make it pass or you're going to change the message. Which means it's time for some live coding. So I thought I would take everybody through TDDing this feature. So let's see. Can everybody see this code all right? All right, so I have my test here. And I've written my test. I was super test first. I just wrote it. I included some gems just because I didn't know how the network was going to be. And then what we're going to do is run it. So the first error that we get is no route matches a get to the root. So we really have nothing in this application. And I'm going to get this running automatically for us so we can go a little quicker. So the very first thing I'm going to do is I'm going to go and fix that. So I am going to go look at the routes. And there's a whole bunch of junk here. So we are going to route to, let's say, our welcome index. Great. Okay, so now we don't have a welcome controller, right? And so now we got to go and make that. Going to make a controller called welcome controller. And there we go. All right, so now there's no index action. So I'm going to skip straight to a view here. I'm going to make the directory app views welcome. And I'm going to go into app views welcome and say hi. And now it says, oh, there's no link name register. Okay, well, we can fix that. Link to register. All right, doesn't really go anywhere. What's the next thing? Okay, now that we have a register link, we clicked it, and we need an email field. So let's not make it go anywhere. Let's just put it here. Let's see, dot label email, and we'll do f.text field. There we go. I'm not going to spend too much time just coding in front of you, especially a boring feature like this one. But one thing I want you to notice is that while we were running through these tests, there's a little code coverage report at the bottom. So if you look there on these last two lines, I've been running some code coverage stuff here, showing that I've got 4 out of 4 lines of code covered. So what would have happened if I had used a scaffold? I would have created a whole bunch of actions and a whole bunch of views that I wasn't really using, including a bunch of automatic Rails tests that would have hopefully covered those actions, but wouldn't have covered the views. And also, I probably would have deleted those tests as soon as they started failing after I had modified the code, right? So one of the things I did here was I just manually went and wrote a controller, and I just used that one view for now. But everything I wrote was just to change that message and to make it pass, and I tried to write the smallest amount that I could to get there. And so what that means is that I really only have 4 active lines of code here. I'm not really sure what those 4 are. I would have counted 2 for the controller, maybe 1 for the route. I'm not sure where the 4th one is. We can check it out later. But it's 100% covered right now. Whereas if I had used some of the generators and maybe got rid of the tests, we would have had some uncovered sections of our code. And granted, they weren't really in use, but they were still hanging out. I mean, there are definitely some applications I've worked on where, I just love that dog. There's definitely been some applications I worked on where there are a whole bunch of views or partials or controller actions that just would never get called, you know? And that can really clutter up and get in the way when you're trying to debug something, when you're working with something. You don't really know if you can remove it or not. You don't really feel safe. So one of the things that we may have run into here is that there were some gaps, right? There were things that I hadn't really finished. And let's say I had gone through and finished that feature. I might have been like, oh, you know what? What if they don't fill out email? If they didn't give me an email address, man, my app is going to do something really bad. I don't know. So one thing that's really tempting to do is right there, just pop into the model and say, oh, validates presence of email. Okay, I'm safe, right? But what I like to do instead is write a note to write a test, not to write the code. To say, you know what, there was this thing, I was totally in the middle of something, and I remembered that I really need to do X. So what I'll do is I'll write these little one-liners. I tend to use mini tests. So I'll say test, user can star posts. That would be something really cool. I'll do a do, little semicolon, skip end, and it'll show up as a skipped test. And I can always correct my test directory for skipped tests later. And that way I can leave little notes to myself and say, hey, these are some things that I want to do later. But I know that since I haven't written a test for them, that I don't want to commit to writing that code now and potentially have it be uncovered. So if you only write what you need to satisfy a test from the outside in, your application will always be 100% covered through your code coverage, right? So there is and 100%, a lot of people call that something that's just unachievable. It's just impossible. You just can't get there. But there is such a huge difference between 1,890 out of 1,890 lines covered and 1,889 out of 1,890 lines covered, right? And that's the broken windows philosophy, that like you've got this building, it has all these wonderful shiny windows, and it just kind of stays that way. But if you break one window, all of a sudden within a week, people have been throwing rocks at that building because it already has broken windows. Who cares if it's got one or two more? Clearly nobody cares about it, right? If you've got every single line covered and you don't cover one, if you decrease it, you are that guy. Like, everybody knows that you did something, and man, we were perfect, and now we're not. It's not, we went from 48% to 47%. Or you're that girl. So let's talk about efficiency here, because that's kind of where I started things off. There were 9 lines in my test. Do you think you could pass that test in less than 9 lines of code? I couldn't. I ran through the example. I think I had about 21 lines of code, right? So let's talk about the line of test versus line of code ratio. So there are a bunch of companies or projects and they're really excited. We have a code to test, or sorry, I totally meant to flip this around and have it say test to code ratio of 3 to 1, right? So you've got so much testing over your code, it's so totally secure. But the way I think about that is, okay, well, when you want to change the behavior of part of your application, you're going to need to change, of course, the part of the code that needs to change. But you also need to change another triple set of tests because you've got it so thoroughly covered that now you have 4x things to change, right? You've got 4 lines for every one of that feature. So one of the things that I think is extremely important and something that we sort of lost track of as we decided that testing everything was super awesome, which it totally is. But I think we need to be minimizing the number of lines of tests per line of code. And the challenge that I would present to you is to try and get your line of test versus line of code below 1 so that you actually have less tests than code around your application. All right, so let's talk about refactoring. What if we decided we were going to use MongoDB for this app? How would your test suite do if you were just like, hey, you know what, Postgres is cool and all, but MongoDB, or vice versa, right? Would your tests pass? How would they do? How much of your suite, more importantly, would break and have to be changed? How much refactoring of tests would have to follow the refactoring of code? How many of your tests would have to be rewritten entirely? I mean, what's the good of them if they're not going to pass when things are working well, right? And what if you're like, oh yeah, Ember.js is super cool, and let's just redo it on Node, right? How many of your tests would actually pass if you were on Node? How crazy would that be, right? But one of the neat things about Capybara is you can point it at a URL and have the tests run. You could actually take a Ruby test suite with Capybara and point it at a Node app and test it. So ideally, none of your tests would fail. Because the behavior of your application should remain the same from that black box perspective of an outside user. But seriously though, I mean, everything would break, right? Realistically, the tests that are specific to the implementation are the only ones that should break. The tests that rely on a system that is Postgres or is Postgres-like should break when you go to something Mongo-like. Which means that if you have lower level tests in your system, they should break when you switch to Mongo because they made sure you were on Postgres or doing something Postgres-like. They were checking things like your queries and your relationships, whereas in Mongo that might be different, and so those tests should. So along those lines, I think we should be minimizing the amount of tests that are specific to the implementation. If you can test your entire app entirely from the outside as a black box, then you've got something that is incredibly free to be refactored. So your acceptance tests, and those are outside-in tests, should be a net for you to use. They should be there for safety and for confidence. You really don't want them to be a cage that holds you to where you are and prevents you from changing or from innovating. Because, I mean, we all love refactoring, right? That's like our favorite hobby. How many people have ever refactored off business hours because it really needed it? Yeah. So what if the tests just kept passing and you could just do that and you were just free to do it, as opposed to having to rewrite all those tests at the same time? So let's talk about a hypothetical situation here. Well, let's say that you have a model test, and I'm using Rails 4 terminology here, so model controller, that's unit functional. A model test on the post models create, to make sure that you can create posts and, you know, works through your database. And yeah, it's not a unit test. That's why we changed the name to model test, is because that was easier than actually writing real unit tests. We've got a controller test on the posts controllers create action. And let's say we actually wrote a view test. How many people have actually write view tests? Yeah, they're kind of annoying, aren't they? And let's say we're being just really thorough here, and we wrote a route test on the posts path and the new post path to make sure we could post to posts path for a create, and that we could even get to the form for the new post path. Did I miss anything? What if there's no link to that page? Right? You have total coverage out of all of these pieces of your application, but you forgot to link the page to it. I remember I think it was about 8 months in to coding Rails. Like, I was totally new to all this. I used the scaffolds as an example. I was doing unit tests and I was doing functional tests, and I was so proud of my test suite. Everything was running great. And we put it up in the staging server, and my boss was like, I can't sign up. I was like, really? But I have all these tests, everything action works, whatever. I just had the form pointed to the wrong URL to post to. It just posted back to the new post page, and I guess way back then, Rails didn't care too much about the actual the verb that you were using to post to, and so you couldn't actually sign up. It was like I had all this great coverage, and I was so proud of it, and it wasn't actually connected at all. So the real question here is, can a user create a post from start to finish? Can they start from nothing and have made a post by the end of it? So without these outside-in acceptance tests, how do you know that your application really works? I think it's one of the biggest confidence-boosting things that you can do to be sure that when you deploy your application to production, people can do all of the things that you've said that they can do. There was one project I was working on where we had a front end in Rails, and we rewrote it to Backbone.js. So we had to rip out all of the views, change all of our controller methods to be supplying JSON instead of rendering HTML. And we had to write this entire front end in Backbone. And it was a huge undertaking. And before I did this, I decided to write an acceptance test around all the major features. And I made sure that they passed all the time as I was doing this refactor. So or at least the ones that I was working on at the time. And then at the beginning of the project and at the end of the project, they still passed. And that was really good because I had to rewrite it 3 times because Backbone.js is really hard to get right on the first try. And I was really thankful that I had that net, that I could keep refactoring because, man, when you do a big refactoring, there are parts everywhere, right? You're ripping things out, you're moving them over there, you have like 6 branches, and someone's been committing to master, of course, while you're doing this. You have to be merging that in, right? Those teammates always writing code. But yeah, it can't always be perfect. Outside-in tests can also be very inefficient. And so there's this sort of idea of super coverage here. Certain behaviors are going to be tested many, many, many times, like prerequisites to some of your tests. For example, you have about 10% of your app is for people like signing up for the first time and visiting your app. And then the other 90% of your tests involve someone who signed in. So when you go to sign into the app at the beginning of every single test, you're covering the sign-in over and over and over and over and over, right? So if you were to think of a heat map of all the views and controllers and models and routes of your application, certain spots get really, really hot because they're used for these tests, and they don't really need to be. So what we should do, and the technique I've been using, is to fill in the cracks. So you still want everything to be covered with an outside-in test, right? You want all the major features to be covered, but there are some cracks, some edge cases, some extra checks that you don't need to write another outside-in test for that's going to do all of the same stuff except one little tweak on one line, right? So for example, for user registration, some potential errors we could have had. There wasn't an email. What they gave us was not a real email. That email's already been taken. There's no password. Maybe we are making sure they don't use secret as their password because that's what I did, and it was probably a bad idea, right? There's a lot of reasons that user registration can go wrong. So one of the things that I like to do is test that bad path just once. Make sure that when someone tries to register and they do something wrong, that they see some errors, right? Because from a black box perspective, the user needs to get feedback on when they've done something incorrectly, but they don't need to. We don't need to make sure that they get feedback in every special particular way. So one of the ways that I'll do this is by abstracting the error handling. So the model does a great job with all the great validates of doing a good way of abstracting error handling at the model layer, and the controller as well. A good controller action should have 2 branches, right? It went well, and it didn't go well. Then you can use things like form objects. When you have a couple of branches in your controller and it starts to get unwieldy, you can make a form object to represent registration. So if it can go wrong in a bunch of different ways, you make this meta object that behaves like a model. And then the other thing that I've been doing a lot more recently is writing form builders. So the idea behind writing a form builder is instead of using Rails' default form builder, you'll write your own such that instead of saying label email and text field email, I'll do something that like label text field with errors, email. And that will give me the label, the text field, do my styling the way I like it, and also display errors when there's a problem. If your form builder abstracts the error stuff, then you don't need to actually check and make sure every field's errors will be displayed. You know that since the form builder's handling that at that abstraction layer, which is pretty high up the chain at the view layer, that anything covered below it, you only need to check once. And then you can leave the combination of the form builder and the form object and the model's validations, and know that you only have to check at the very top in your acceptance test, the happy path and the bad path. And then what you're going to do is trickle down through all the other areas of your app, getting lower and lower down, and you can fill in with unit tests there. Maybe unit test your form builder, or maybe just have one acceptance test that checks your errors, make sure they all look good. And check your, like you don't really need to check the controllers at all, because that should be delegated properly down to those form objects. So you're going to be unit testing all those lower branches. I was saying before, ideally, you have this wonderful big net of black box tests, but due to that efficiency, it does make sense to fill in the cracks with unit tests. But I still like to see a large percentage of acceptance tests and then a smaller percentage of the lower level unit ones. So for trading flexibility for efficiency. So What we don't want to do here is make an application that's not very flexible. We want something that's very flexible so that we can move very efficiently when we're writing code. I mean, I've definitely been on freelance projects where the client will say they want something in a particular way, and then they'll change their mind, right? And that's not bad. Agile means you're embracing change. You're going to put this thing in front of users, you're going to realize you were totally wrong, and you're going to change your mind. Being able to change as little as possible to get from one place to another place is very important as far as efficiency goes. So, what that means is there are a whole lot of big judgment calls involved with testing your application, right? You have to decide how much am I going to test from the outside, where am I going to fill in the cracks with unit testing, and you know what? That's where you earn your dollars, right? We're all very smart people, and we're making these apps, and it's up to you to make those judgment calls. I really enjoyed the panel this morning where we talked about rules, rules being useful guidelines, and being able to recognize, and Sandy's question, why are those rules in place? Why am I following that rule? And sort of questioning it and understanding what's surrounding the judgment call that you're making. So what are the real goals here? We want something that's expressive. We want minimal lines of text to describe the requirements. So that means that when I write my acceptance tests, I want them to be nice and short and expressive, which means we get to use wonderful Ruby to make our code awesome, even in our tests. We want some resilience. We want our application, we want our test suite to be to survive under that internal change, under that refactoring. So when you decide you want to switch from Postgres to Mongo, we want our test suite to be very resilient during that change. Security, not to be confused with a talk right before this one. This is security as in blanket and not as in hacking. You want to have confidence in your application. You want to know that when you ship it, all the things that you've tested mean that people can do all of the things that you promise that they can do. And efficiency, the amount of effort it takes you to achieve all of those goals. So that's both in the initial implementation, when you're writing your code, when you're doing the TDD, but also in the future maintenance of that code. So a couple of quick rules of thumb that I use, but these aren't real rules, right? Or take them as real rules and then judge them for yourself. I like to test as far out as I can. So try and come from as far outside the application as I can, because I can usually write shorter tests and I can make them a bit more general. I can use, and I know that the whole interaction is going to be covered. Here's a cat. Minimize lines of tests. Tests are code too, and I think that's something that we're realizing more and more as we write more and more tests. They're not scripts, right? It doesn't mean that just because they're in a different directory and it's not part of what goes into production, that it's not real code that should be treated well. So use abstraction when you're doing your tests. There was a lightning talk last night about great ways to abstract functionality in RSpec, and there's a shameless plug for Gemma Road. That's abstraction for acceptance testing, right? So make lots of helper methods, make helper classes. How many people have made a class that was just for testing? That's awesome, right? We should be doing good object-oriented programming in our test code as well as in our application code. Maximize the code coverage. So what I'm talking about here is the code coverage report that we were seeing earlier, right? You want your entire application to be covered. So it's this constant balancing act between the small, short tests that can cover a large amount of your code base. And I think that is true value in a test suite, is knowing that you're confident in that entire suite, that it's working, that things are being properly covered, and that it's also very small and resilient. So that's outside-in testing. Thank you. Great. So questions? Yeah.
How do you feel about fixtures or other methods to set up initial state when you're testing?
I have recently gone back to fixtures. I don't think that it's fixtures versus factories. I use both. And there are certainly some cases to use fixtures because you know what? They're really, really fast, right? And they set up your application in a way that you can use to say, this is sort of what a basic application looks like. I think what happened when we started using fixtures a lot and started switching over to factories was that people used fixtures to make very, very specific cases, and then their application had all these crazy specific cases they had to sort of weed out. But I think fixtures are great for some of the high-level stuff. I almost always have a fixture for the users of my application, so I can sign in quickly without having to go through registration. That's one of that super coverage hotspots, right? So yeah, I like fixtures, and they're very quick. And they do work well, and they do still get, I mean, they're worked on, they're maintained, they're a good part of Rails, they can reference each other really well. They can be a little tricky because they go right to the database and not through the model layer, but I think that's also part of the power. So I do like them, and I've been using them more. Yeah?
In a continuous integration setting, are there performance implications to which tests you're running to get instant feedback or waiting for the capybara outside?
So yeah, anticipated question. Speed is certainly an issue here. I think as a community, we haven't done as good a job at parallelism as we could be doing. I spoke about test suite speed 3 years ago at a couple of different places, and at the time I had written something to run my tests in parallel, and it becomes a real unmaintainable mess because the test suites themselves are not actually designed to be run in parallel, and parallelism is something that's usually very core to the implementation of the frameworks that we use. I think we're starting to see parallelism grow, but it's 2013. Everybody here has a quad-core machine. Some people have 8 threads, whether they're virtual or not, and we don't use them at all. Like Bundler just got that parallel bundle install on a pre-release, right? And that was something that should be very easy to parallelize. So I think there's a lot of work to be done there. There are 2 existing solutions, and there's a couple more like Deep Test. Parallel Test is a good one. TDDM is a software as a service that'll run your test suite in parallel for you. I also have a really crazy alpha version of something that shards your test suites using Docker, so that any dependencies you have, like if you have a global Redis database, it's sharded within a Docker image. We talked about fixtures. So yeah, speed's definitely an issue, and we're well aware of it. And I think we just need to keep working on it, especially parallels. Yeah.
So you get a feature request that applies JavaScript. Are you bringing in Capybara WebKit, and are you going to Java?
So for JavaScript, I like to use, I still like to use Capybara, because to me the important thing is how a user interacts with the application. And that's the same sort of question of using Capybara WebKit, or I like to use Poltergeist with Phantom.js. I think it's faster and the stack traces are nicer, and Thoughtbot uses Poltergeist. But the same argument applies as before. You want to trickle down to the unit layer the same way in JavaScript as you do in your Ruby. Cover the acceptance layer first, and then work your way down as necessary. Yeah.
So you said it's a good thing to have, primarily outside tests, outside tests for when you change the technology that's like underlying your app. But sometimes you'll have unit testing that's based off like your first implementation. Let's say you move from a Rails front end to a backbone front end, and then those unit tests that you had originally written break, and you'll maybe have to rewrite them backbone. Like, do you try to refactor to avoid having any unit tests? Is there like a refactoring cycle on your test suite so that it can be more portable?
Well, ideally you're going to start from the outside to begin with, but I totally see where you're getting at. And when I did that backbone rewrite, the first thing I did was write all of the acceptance tests so that it was actually covered at the acceptance layer, because I knew I was going to need it to remember how everything worked. And as I move to something that's more acceptance test oriented and outside in, I will remove those unit tests. Because if they're covered by my acceptance tests, then I don't want to keep them around, because at that point, they're just weight that's pulling me down. But yeah, if you have something that's, and you were talking about something that is under heavy change, on the flip side of that, when you have something that does not have a lot of churn, it's very stable and it doesn't change much, and maybe it's highly dependent on the system, then I would say that is a good candidate for something to have some unit tests, because if it changes, you are really doing something crazy with your system, and then you do need to go and revisit that section of make sure you're doing a good job as you do that refactor. So again, it's that difficult job. You gotta cut it. Okay, I'll hang. Sorry, I'm gonna hang out here. I think we've got 10 minutes in transition to the next session. I'm happy to answer more questions, and you can reach me on Twitter there as well. So thank you.